This might not work. Okay, so first thing, like I said, we need to go ahead and invert our fraction, right, our exponent, and use that on both sides. Anything you do to one side of your equation needs to be done with the other. Now they're saying, remember that there are two real even roots of any positive real number, and there is exactly one real odd root of any real number. So what does that mean? If I have a positive real number and you take an even root for it, right? So you're taking square root, fourth root, whatever, you're going to get two answers. Because remember with square roots, we always get one positive, one negative, so that actually translates to all even roots. Now if it's an odd root, like a cube root, fifth root, seventh root, you only get one answer, because the way these odd roots work is if you have like -8, then its cube root is going to be -3. If it's +8, then its cube root is going to be +3. So if the original number is negative, your root's going to be negative. If the original number is positive, your root's going to be positive. So that's why you only get one out of those. They're saying if your m is even, which will be this m over here, and your k is a positive value, then that's when you're actually going to end up getting your positive and negative two answers. If m is even, but your k value is negative, they're saying you're going to get no real solution. But what kind of solutions we get in that case? Imaginary, right? Because whenever this k is negative, that's when you're going to get into imaginary numbers. So technically, yes, you have no real solution, but you will still have imaginary solutions coming out of that. And then they're saying when m is odd, you're only going to get one real solution. So let's see how we can go ahead and simplify a problem like this. So the first step we're going to start out with is taking our equation and we're going to raise it to the reciprocal, right? So 4/5 will become 5/4. Now what should I do with that negative sign? Keep it? So will I include that when I'm raising it to 5/4? Actually, I will. You know why? Because I cannot have x left with a power of -1 either. I need my x to be a positive exponent, you know, everything working. So I'm actually going to raise this to -5/4, -5/4. Okay? So what happens is, and you should probably, this is where we'll need to remember some rules of exponents. So if you have one base raised to an exponent, and I raise that whole thing to another exponent, which is what we have here on the left-hand side, what do? Yeah, very good. You end up multiplying your exponents together. So you end up multiplying m times n, which means on this side, my negative times negative will become positive, and the 4/5 will actually end up canceling out the 5/4.
Why do you, so when you reciprocate your exponent, why do you put the negative on the 5 and not keep it on the 4?
Oh, it's on the whole fraction. Because here, your -4/5 is on the whole fraction, right?
Oh, okay.
So it's not really associated with the number as much as it is with the entire fraction. Does that make sense? Okay. Any other questions? All right, so that's why we need to take our negative sign when we use this exponent, so that the two negatives will end up becoming positive. They cancel each other out, and you get just x on the left-hand side, which is what we wanted. But that means I have now introduced a negative on my 16. So what rule do I use there? What do you remember rules of exponents with negative exponents? Maybe? No? Completely gone? Okay. Anybody remembers it? Here, Exie.
It turns into a fraction.
Okay? So if I have a to the -m exponent, how do I make it into a fraction? What should go on the top?
M.
No.
A.
1. Yeah, you actually make it a denominator of 1. So you put 1 on the top and you move your a to the m on the denominator. So that's the rule for exponents. Anytime you have a negative exponent, a to the negative m will become 1 over a to the m. So that's actually what's going to happen on our right hand side. You will end up with 1 over 16 and then the power of 5 to the 4th. Now, if you type in 1 over 16, 5 to the 4th in your calculator, you're going to get a decimal answer. We're not looking for decimal answer, so you don't want to do that. What we're going to do is simply figure out what 16 to the power of 5 to the 4th is. So just to show you, remember this is going to be the 4th root. The number on the denominator tells us what the radical is going to be. So it's going to be 4th root of 16. And I'm actually going to put the 5 on the outside. So we're basically thinking what number multiplied into itself 4 times will give me 16? 2, right? This 4 times 4 will give us 16, but 2 times 2, and let's see if we can do that here. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, right? So 4th root of 16 is actually 2, and then we do 2 raised to the 5th power, which means to this, I'm actually just going back and multiplying by another 2, right? So 16 times 2?
32.
32. You're actually going to end up with 1 over 32 when we clean this whole thing up. Jamesy, did I lose you somewhere? Where did I lose you?
I don't know.
Okay, so coming back, the number on the denominator tells us what our radical is going to be.
Right.
So that's the 4th root.
Mm-hmm.
So that means some number has to be multiplied 4
So
times.
first you square 4th root of 16 first.
Yeah.
That's step 1, which is where the 2 came from.
Which is where and this is something you could actually plug into your calculator also.
Right.
You just put the 4th root of 16, which will spit out a 2.
And then you just kept the 5.
Yeah.
Okay.
And then you go back and do 2 raised to the power of 5.
Yeah.
Which will bring you to 32.
Okay, that makes sense. Thank you.
Okay, good. Did anybody else have questions on that? So you can see, since we actually are going to maintain a fraction in our answer, if you were to type this directly into your calculator, the 1 over 16 to the power of 5/4, you will end up getting a decimal answer. And depending on what calculator you have, it may not be able to convert it back into a fraction. So what you want to do is just calculate what the denominator is and leave it as 1 over whatever that number will be once you clean it up. So in this case, we end up getting x as 1 over 32. Now, if this guy was not a negative exponent, if you just had x to the 4/5, then you would have actually just had 32 as your answer. It's the negative which is making this into a fraction. Okay. Any questions on number 5? So that was, yes.
Last time, we put the solution set, which was a negative 1 over 3.2, 1 over 1, I don't know. It was like the solution set was the negative and a positive.
Did we have 2 answers on that?
Mhm.
Yes, we did. Thank you for telling me that. Yeah. And I did skip that step because we are having a 4th root. Yeah, you are going to have, well, I guess I'm going to put it on the outside. Positive and negative 32. Thank you. I didn't even think about that. So this actually goes back to this step right here when they said if your m is an even number and you have a positive k value on the right, you should get a positive or negative on your solution set. And since we had ended up taking a 4th root, because positive 2 and negative 2 both will give me 16, right? So yeah, we needed to have, I don't know if you guys can see that, but there's a plus or a minus here, plus and a minus here, which will transfer when we bring it with our denominator. Thank you. All right. Anything else? Okay, equations of the quadratic type. Now these ones here basically mean, can we take the equation that is given to us and convert it into something that will look like a quadratic equation? And the main reason we are doing that is so that we can use methods for solving a quadratic equation. So if you can take your x to the fourth minus 9x squared plus 20 equals 0 and make it look something like this, then I can use the quadratic formula, I can try factoring, I can try any of the two other methods if they apply in this case, and I'm not really sure what will apply here. So how do we go about converting these into equations that will look like a quadratic type? So let's actually come over here, and I've got x to the fourth. I may need to calibrate this 9x squared plus 20 equal 0. So your guidance here is going to be, one thing you will notice in the instructions that are mentioned above, we're trying to convert this in the form of au squared plus bu plus c equals 0. So instead of using the original variable, we're actually going to bring in the variable u. So what we're going to do is actually use the middle term to help us guide. The middle term variable is what we're going to define our u to be actually. For all of these examples, we're going to do the same thing. So always go to the middle term, not the number, but just the variable portion is what we define our u variable to be. So we will say, let u equal x squared. Okay, so that means what will happen if I square these? So if I'm going to put a square here, that means I have to put a square here. What will that do? So think about this. If I have u equals x squared, and I put a square on both sides, what do we end up getting?
X to the fourth.
Yeah, you're going to get x to the fourth. So you are defining u squared as x to the fourth, which is very, very convenient for us because that happens to be our leading term. So we can define that as u squared. So as you can see, we're taking a problem that was a fourth degree polynomial and rewriting it as a second degree polynomial by making this substitution happen. So let's do our substitution here. We are going to have instead of x to the fourth, I will now have u squared minus, instead of 9x squared, that will now become 9u, and then of course plus 20 equals 0. So that's what I was kind of saying. We went from a fourth degree polynomial to a second degree polynomial, or a quadratic equation. Any ideas on what we can do to solve this? You can try quadratic formula, but this is actually simple enough. You guys just did factoring. So what do you think it should be?
U minus 5 times U minus 4.
U minus 5, U minus 4. Do we think that works? No, Jose? Yeah? Okay. Negative 5 times negative 4 will give me a positive 20. Negative 5 plus negative 4 will give me a negative 9, right? Then what did we do when we were solving quadratic equations? How would I go about solving this guy? Yeah, set them equal to 0. So u minus 5 equals 0, or u minus 4 equals 0. So we add the 5, and you get u equals 5 from here, and what will we get here? But obviously we are still working only in terms of u's at this point. We were originally with x terms, so we will need to go back and bring that x term in. But at this point, through this process, does anybody have any questions? Any part that did not make sense or you'd like me to go over again?
Yeah, why did you raise the x squared to 2? I lost that.
Okay.
Oh.
So the reason I did this part, right,
Yeah.
was to show you that when I use u for my middle term, u square usually comes out to be the leading term. So just to show you why we are calling this u square. So the idea was if I started out by calling my middle term as u, and I raise both sides to the second power, when I get u squared, that will be x squared to the second power. So 2 times 2 will give me 4, which is the same thing as my first term. So I can call this guy u squared, call this guy u, and that's actually where my quadratic form or quadratic type is coming from. Yeah? Questions? Okay, so let's come back to our original equation. So if I go back and say, okay, u equals x squared, right? So if I'm using that, I had u equals 5 or u equals 4. So instead of u, let's replace it with x squared. So that will be x squared equals 5 or x squared equals 4. Now what are we going to do to get our x's?
Square roots.
Yeah, very nice. Square roots. So you're going to have x squared equals, and if I take a square root here, remember that's going to be plus or minus square root of 5. So the square and square root cancel out on the left-hand side. We get x equals plus or minus square root of 5 here. What will I get on this side?
Plus or minus 2.
Yeah, very good. So you start out with plus or minus square root of 4, which cleans up into x equals plus or minus square root of 2. So your solution set is going to be negative square root of 5, positive square root of 5, negative 2, and positive 2. And if you remember, we had also mentioned this last time, since this is a 4th degree polynomial, at most we should have 4 solutions, and you can see, of course, we did end up getting those 4 solutions in this case. So just to kind of go through the steps one more time, we start by making our u substitution, and the u substitution will always start with a variable in the middle term. So in this case, we went with x squared, which led us to u squared would be x to the 4th, so that's our leading term. Using that, we make our substitution. We've got u squared minus 9u plus 20. By factoring, we were able to come up with u equals 5, u equals 4, and then we basically went back and brought that x squared back in for u, right? And then figured out what our final x values should be. Questions? Yes, Amy?
So why don't you simplify the square root of 5 into the 5i? Why don't you make that like an imaginary?
Oh, because there was no negative on the 5. Oh, right? There would have to be a negative that the 5 would be bringing in. Okay, very good. Anybody else? Anything popping up?
So the negative has to be under the square root sign.
For it to be I. Yeah, so if you would have had a negative inside with the 5, then we would have had the i's show up. Okay. So what do you think happens with number 7? go ahead and we've got x squared plus x, and that is the whole thing to the second power, minus 8 x squared plus x plus 12. So what will our u substitution give us? You kind of think like you're thinking.
Yeah, I'd say u plus x, but I don't know what a singular x would be.
What the singular x would be, okay? Anybody else? I will come to you if nobody gives me an answer.
Is it u?
Go ahead.
I said, is it u equals x squared?
Okay, is it u equals x squared? What were you gonna say, Amy?
Doesn't it equal like everything in the parentheses in the middle term, like so x squared plus x?
Yeah, so you actually gotta take that whole parentheses, because if you'll notice, this is the whole parentheses to the second power, and this is that same parentheses. Is that what you were gonna say? Yeah, so you have to take the entire thing as your u, so it will be, this guy here is u, which then we know this guy will become u to the second power. So we would say, let u equal x squared plus x, which means if I were to take u to the second power, that would mean I take these parentheses to the second power, which will give me my leading term. Okay, so let's do our substitution. We will have u squared minus, so we have that 8 which is still left behind, so that's going to be 8 times u, 8u plus 12 equal 0. I would again recommend factoring, but like I said, your quadratic formula will also work because these are equations in a quadratic form. Alrighty, so can somebody tell me if we factored, what will we get as our factors here?
U minus 6 and u minus 2.
Okay, you said u minus 6 and u minus 2? Okay, so when I multiply negative 6 with negative 2, I get positive 12. When I add negative 6 and negative 2, I get negative 8. Wonderful, that will work. So just like we did in the previous example, set each one of these equal to 0. And we've got what as our u values?
6 and 2.
Yeah, 6 and 2. Positive 6, positive 2. Okay. Now what should we do? Once we get our u values. What did we do in the previous example?
Made them x squared.
Yeah, we went back to our x squares. So that's exactly what we're going to do here. Since we know we define u as x squared plus x, we'll bring in our u equals 6 or u equals 2. And then rewrite these u terms as x squared plus x equals 6 or x squared plus x equals 2. Okay. I want you to take a second and think about this. How are we going to move forward from here?
We have to set both of them equal to 0.
Yeah, we have to set, he is just beating you, isn't he? Yes, you have to set each of them equal to 0, which means we move what?
The numbers
Yeah, move the numbers, move the 6 and the 2. So I'm going to subtract 6 here, bring it to the left, and this will end up becoming x squared plus x minus 6 equal to 0. Or when we subtract our 2 here, we end up getting x squared plus x minus 2 equal to 0, which again, you can actually try factoring at this stage also. Let me give you a hint in case you're wondering. Since my constant terms on both sides are negative, that means my factors will be one term positive and one term negative. So you will have opposite signs on your numbers. Yeah. I thought I was, yeah.
Never mind.
You sure?
Yes.
Okay. All right, come on. Who wants to try? Raymond?
I'm having a hard time figuring out how these both factor. I can't figure it out.
Okay, look for numbers that multiply to give you -6, but add up to give you +1. Was it?
For the first one, is it x plus 3 and the next one is 2?
Very nice. X plus 3, x minus 2. Because when I multiply, positive and negative will give me -6. And I want my 3 to be positive, right? So that I can get +1. So +3, subtract 2, we're going to get +1.
And the other ones, is it x plus 2 and x minus 1?
X plus 2, x minus 1? Yeah. So x plus 2, x minus 1. Since again I read +1 for my middle term, that means my larger number has to be positive in this. So we're basically repeating what we did here. You will take each one of these factors, set them equal to 0. So I will have x plus 3 equals 0, or x minus 2 equals 0 on this side. And then, of course, x plus 2 equals 0, or x minus 1 equals 0. So what are those x values going to be?
X minus 3,
Minus 3,
x equals 2,
2, very good.
and then x minus -2,
-2,
and x equals 1.
and x equals 1. And again, since we were actually a 4th degree polynomial again, you can see we ended up getting 4 numbers in our solution set. So we've got -3, -2, +1, +2. Anybody have questions on any parts of this problem?
When you're doing the factoring, does it matter which order you put the positives or negatives in?
Are you talking about does it matter if the 2 has a positive or not?
No,
Or are you
like,
talking about switching my
like you
parentheses?
put like x minus 2 first before you put x plus 3.
Yeah, that wouldn't matter. Yeah, so you could have x minus 2, x plus 3. You could have x minus 1, x plus 2. As long as the sign is with the number, it doesn't matter if you switch those parentheses. Because it's the same thing as multiplying 2 times 3 or 3 times 2. You're still going to get 6. So it doesn't matter if you switch your parentheses, but just the signs have to be with the number.
Yeah.
How many of these will be on this?
At least one. I haven't really printed your test out yet, so I'm not really sure what's going to be on there. Because I use my MATLAB to do it, so it kind of is auto-generated, so that way I'm not putting my influence in there. So, but I would assume at least one will show up.
It'll be one like number 7 or one like number 6.
Ask my math lab.
I'm just saying they're two pretty different. That's
Yeah, they are. And we're actually getting ready to look at a third type in this. So that's why I'm asking you, do you have any questions at this point? Okay. If you think of something, let me know. So this is actually the third type. So we had this one here, this one with the binomial term in there, and we're actually coming back to our rational exponents here. So let's go ahead and take a look at what this looks like. We've got x to the 2/3 minus x to the 1/3 minus 6 equals 0. Okay, so again, let the middle term guide you in this case, right? So our middle term is x to the 1/3, so that entire thing is actually going to become our u term. So think about this. If I say, okay, my u is going to be x to the 1/3, right? Then, if I take u to the second power, that means I am taking x to the 1/3 to the second power. If it helps, you can think about it as 2/1, right? We multiply our exponents. So what do you think happens when I multiply my 1/3 with 2/1? It will become 2/3. So it becomes x is 2/3. And obviously, as we hope, that becomes our leading term. Yes?
You got the u squared. Okay, so when you say then u,
Yeah, so
the
this means
second, I'm
if
not
I'm starting
squaring.
out with this definition of u equals x to the 1/3, and I'm just saying, okay, what happens if I put a square on both sides? Will it bring me to my leading
that.
term?
Okay.
And it should, because otherwise we just did these problems for no reason.
Okay.
Because they have to work out. Otherwise we cannot convert them into quadratic type. Okay, so let's go back and do our u substitution here. So this guy will become u to the second power minus u minus 6 equal 0, because I have no leading coefficients in front of any of those. So you just have u squared minus u minus 6. And again, you will be able to factor these guys out.
U minus 3 plus 2.
U minus 3, u plus 2. Yeah. Okay, so let's see. -6. Yeah, very good. Nicely done. So what are the two u values here? 3 and -2. Yeah, very good. +3 or -2. So let's see, what can we do with these guys here? So again, we defined our u to be x to the 1/3. If I'm bringing in u equals 3 or u equals -2, what will we have? So replace that u with x to the power of 1/3 or x to the 1/3 equals -2. Okay, so think back to example 5, was it? What will we need to do to get our x's by themselves? Yeah, so just invert your exponent, right? And apply it to both sides of your equation. So this will become x 1/3 will be raised to the power of 3/1, right? Same thing on the other side, 3 raised to the power of 3/1. So when we clean that up, what will we get? when I multiply these, I will basically get 3 over 3, which will become 1, right? So these guys actually cancel each other out, which is what we wanted.
X equals 9. No, sorry. 27.
Yeah, because you're raising 3 to the third power, right? So it's 3 times 3, which is 9. 9 times 3, which is 27. All right, very good. So he's one of our answers. What do you think this guy will become?
X equals -8.
Yes, very good. It will become x equals -8. So we're raising again, same thing, both sides to 3 over 1. These guys here cancel out, giving us x equals -2 times -2 times -2, which will give us the -8. So your solution set is going to be just these numbers, -8, positive 27. And it doesn't look like it because you have those rational exponents. But if for a second we ignore that 3 on the denominator, this is an x squared problem, right? So technically we should kind of see 2 solutions at the most, which is what we came up with. Anybody have questions on this example or its friends? So it takes a little while. You kind of have to practice a little bit. I would recommend you guys to practice a couple from your homework. And if you run into something, let me know and we can definitely look at it if it's still not making sense. So that I believe brings us to the last type of equations we are solving, which is the absolute value equations. And we looked at absolute value equations again, either in 1.1 or 1.2 of this chapter, but of course we're kind of building it up with polynomials this time. So you've got x squared minus x minus 4 equals 2. What do we remember about absolute values? What did we talk about in terms of absolute values?
Because distances measuring distance.
Yeah, what were you gonna say?
Well, I was gonna say that no matter what it is, it's the same distance from 0, which is basically
Yeah, so basically remember, we're always talking in terms of distances when we're talking absolute values. So you can think about it being the same distance from 0, or since absolute values are distances, they're always going to be positive. So either way, however you look at it, absolute values have to be positive, but we know absolute values can come from positive or negative numbers. So let's see how we can simplify this guy. You've got x squared minus x minus 4 inside the absolute values, and this is equal to 2. So basically we're saying whatever this distance is, x squared minus x minus 4, it's going to have a distance of 2. So as Trey said, if you're talking about distance of 2, I can get that distance of 2 on the right-hand side of my number line. I can get that distance of 2 on the left-hand side, which would be my negative side. So when you're setting absolute values up, what do we do? Go ahead.
Is it equal to 0?
No.
Right?
Not yet.
so when it goes -2 and -2.
Yeah, we always break it up into positive and negative parts, right? So when I set this up, you will have x squared minus x minus 4 equal to, or this is the negative side, x squared minus x minus 4 equals -2. So you always set it up into 2 parts because my distance can be 2 from the positive side, my distance can be 2 from the negative side. Okay. Now we get them to be equal to 0, which means we gotta subtract this 2, bring it over here to the left, which will give us x squared minus x minus 6 equals 0. And same thing on this guy. Now since this one was set up as -2, we will make it +2, which will give me x squared minus x minus 2 equal to 0. Alrighty. Let me see what you guys come up with for this one.
I don't know why I have those numbers down.
Alrighty, so you guys have x minus 3, x plus 2 for this one, and then x minus 2 and x plus 1 for these ones, right? So this one here will give me you're going to get x equals 3, x equals negative 2, and then these guys will give you x equals 2 or x equals negative 1. So our solution set is going to be, let's see, negative 2, negative 1, positive 2, positive 3. Did anybody have questions on this? Alrighty, what do you think we need to do for number 10? So here we've got absolute value of x equals absolute value of x minus 1. So we've got absolute value on both sides, right? So we're basically saying you should still get the same distance from both sides, but that also means I can get my distance on the positive side of the number line or on the negative side. So we still have to set this up with the two different options, one positive, one negative. It's really up to you how you want to set this up. The first one, of course, will be straightforward because you just keep them as it is without the absolute value signs. The second one, since I am in the habit of putting negatives on my right-hand side, I normally just go with negatives on my right-hand side for this one also. So one positive option, x equals x minus 1, and one negative option, x equals negative, and then the whole quantity, x minus 1. So you can see the reason I have those parentheses on there so that I will remember to distribute that negative sign inside my parentheses. So you know what, we'll go ahead and solve this guy first. So you've got x equals negative x, negative times negative will become positive, positive 1. What should I do next?
Add the x.
Bring the x on the same side. All right, so we can add this x, bring it over to the left, which will end up giving us 1 on the right-hand side, 2x on the left. So what's your x? Yeah, very good, 1/2. X equals 1/2. What will this guy give us? Where do I start with 10? Same thing, bring my x on the same side. What will happen when I bring my x on the same side? Yeah, it will cancel out, giving you 0 equals 1, which is a false statement, which means he's done. You've got one answer, right? X equals 1/2. Questions on 10? We're okay? Yes, Amy?
So when you have absolute values on both sides of like the equal sign, you only have to make one side of it negative when you're
Yes,
solving? Okay.
yes. You know, technically, for this side here, you could have also done negative x and just kept your x minus 1 as positive. So with this particular problem, putting the negative on the left-hand side also works, but like I said, I'm actually used to putting the negative on the right-hand side, so I just went with that. But just to keep in mind, you will not always lose your other part. That will just depend from problem to problem, okay?
You mean it will be false? Is that what you're saying?
Yeah, I mean, you could get another solution
Good.
from here when you have absolute value on both sides. So this is just an anomaly in that process. So does that help answer your question? Yeah? Okay.
And then when you have absolute values and you try to solve, you can just drop the absolute value. I mean,
Yeah.
just to drop the lines.
Yeah, exactly. Like if you go back to the previous one, you will also see that we dropped the absolute value symbol. We set it up once as it is, just without the absolute value, and then we made the other side negative. And that's the same thing we're doing here. Kept it as it is without the symbols, and then just make sure we put a negative on the other side. Anybody else? Any questions? Okay. Going back to our last example is the function d equals square root of p minus square root of p minus 400 gives the monthly demand for custom-made suits in terms of the price p in dollars. What price is the demand? For what price is the demand 10 suits? Man, I can't read. All right, what are we gonna do here, people?
Replace your D with 10.
Yeah, replace your d with 10. Okay, do I have enough space to do this here? So they're telling us what is the price when your demand is 10 suits. So in our equation, okay, if this is 10, I have square root of p minus square root of p minus 400. What do we do?
Set it to 0.
First, you square both sides.
This is actually the one you're not going to see on your test, like number 4. From the handout. The evil one. So, yes,
So I'm just going to get rid of the square root or just the negative.
one more step before we get to that. So you can actually move whatever you want just to keep things simple. I think I will actually move the square root of p, because if I can get this as an isolated radical, the square will take care of the negative sign in here. So I'm actually going to start by subtracting both sides with my square root of p. Move this guy out of the way. I will have 10 minus square root of p on the left, and I will have negative square root of p minus 400 on the right. Raymond? You sure? You had a look of like, I have a question. No? Okay. This is where, since I have isolated the square root of p minus 400 by itself, I will actually go ahead and square both sides of my equation. What will we need to do on the left-hand side? Yes, FOIL. Right-hand side, the square will make my negative times negative into a positive, and the square and square root will cancel out, making that into a positive, and you are left with not a square root. You are left with just p minus 400 here. What do I get when I take FOIL of my left-hand side? 10 times 10?
100.
100. You are doing 10 times negative square root of p twice. So 10 times negative square root of p will give me negative 10 square root of p. And then I'm doing it 2 times. So 10 times 2 will give you negative 20 square root of p. And I will need to create some space in here. Square root of p times square root of p. Because the square and the square root will cancel out. I will let you guys do the FOIL because I showed it to you last time. So I will let you do that on the side if you want to. But once we get to this stage, we of course want to again set it equal to 0. And to do that, I guess we'll add 400 to both sides. Which will give me 500 minus 20 square root of p plus p. And we still have that single p on the right hand side. You want to move that too?
Subtract that p.
Yeah, subtract that p, which will give us what? 0 on the right hand side. What happens on the left?
It's just 500 minus 20.
Yeah, the p will also cancel out on the left hand side. So these guys are actually gone, which makes our life so much more easier. Unlike example 4, we have that independent p canceled out. So we actually will be able to solve this a lot faster than we were able to do in example 4. Okay, so again, we still have to isolate that radical. So start by moving the 500 and then get rid of the 20. So if you don't want to mess around with negative signs, let's go ahead and move that 20 square root of p on the right hand side. If you move the 500, that's also fine. You will still get the same answer. And then just divide both sides by 20. So my zeros will cancel out. 50 divided by 2. Or 500 divided by 20. 45. 25.
Square both sides.
Yeah, to get rid of the square root, square both sides. On the left, on the right, the square and square root will cancel out, giving us p and 25 squared. 625. And this was what price? So that will be dollars. What are you saying? No, I don't want to do that. For what price is the demand 10 suits? So 625. Demand will be for 10 suits. Okay, questions on the process that we went through? Amy.
So earlier in the problem, because it's minus the square root of, where did that negative go? Because it
Show me where you're at.
just at the very top it says minus square root of p minus 400, and then right underneath
Right
it says
here?
plus. Yeah.
Okay.
So
So here, what happened was you had negative square root of p minus 400 that we squared, right? So since we squared it, technically that's negative of this number multiplied into itself, right? So that's where the negative times negative becomes a positive. So yeah, that's what I just did, was change it to a positive, so you knew, because what has happened in the past is I would cancel out my square with the square root, so students would end up thinking that negative still stayed behind, and I didn't want you to think that negative stayed behind, so that's why I made it positive. So you knew what happened with that, but that's basically what's happening with the square, it's becoming positive. Because the other thing you could do is, if you wanted to not mess around with the negative sign, is move the square root of p minus 400, but then move the 10 to this side. So I just got lazy and I didn't want to make two changes, and so I just moved the square root of p. But that would be another thing. Move this guy to the left-hand side, he becomes positive, and then move the 10 to the right-hand side, so then you would actually end up getting square root of p and then plus 10 after it. But you're still going to get to the same result no matter how you solve this. Anybody else? Any other question about this problem? Okay. So this was the last one for section 1.6.